maybe if I analyze my data a bit or talk to people about what I'm doing and to try to keep the data at a good level, or not doing, I should say, I might find that GOR has like a 40% error in the water cut, maybe 10% error for some other things. I can look at that, what's called error propagation in the calculations, and I can calculate the error range for each of these pieces as I go through the calculations. And I might find out that ultimately, because the static bottle pressure has an error and the flowing bottle pressure has a big error, that together they end up causing 100% error maybe in the calculation ultimately. So 100% error, what does that mean? That means in my profit, maybe I have a range of minus 119% profit to 319% profit. So if you look at that on a kind of a histogram type of thing, then you could say, all right, maybe if I use the central number, if that's what's really happening, if I knew things perfectly, I would make this decision. But there are going to be decisions like this where I end up making the wrong decision. I look at that and go, no, I'm not going to do that work because it apparently is a negative profit because I've used the wrong data that would come out of instruments that have, or measurement devices or whatever, that would have this kind of error. So I can make a mistake here. So, if I tightened up the data a bit, maybe I changed the error to GOR of 10%, and tightened some of the other things up, I would have a narrower range of things that could be indicated in my analysis. My error would propagate in a tighter range. And then if I said, oh, I have a 25% cutoff, then okay, well, maybe almost all the time I make the right decision.